Assalamualaikum. Today we are going to learn how to analyze frame with side sway by using the moment distribution method. This is example 12.7 taken from textbook, Hibbeler textbook. Alright, we are going to identify or determine the member and moment. So the question is given as shown. This is the frame, side sway frame. This is side sway frame due to unsymmetrical condition. So the frame will side sway, and we assume the frame is side sway to the right side. So to start the solution, we know that to determine the member and moment for side sway frame, we have to use this formula. This is final end moment, and this is equal to m naught plus r divided by r prime times with m prime. So from where this equation comes, it is actually come from the principle of superposition. Alright, this is the final end moment or the moment from original diagram, original frame. Okay, m naught is the end moment for the non-sway frame. Okay, the m prime is end moment for side sway frame. And r divided by r prime is the correction factor. Okay, this equation is actually comes from the idea from the principle of superposition. So if we draw the free body diagram based on the principle of superposition, we have like this. The idea of using this principle is we have to analyze the FEM due to external loading and due to side sway separately, since FEM can be used to analyze external loading as well as delta. Alright, so this is the original frame. This is subjected to 8 kilonewton per meter, W along BC. Okay, and this, the original frame has, this is original frame. Okay, it has external loading. It also has side sway. In this case is delta. Alright, so to analyze this frame based on the principle of superposition, we have to equal this with two diagrams subjected to different type of loading. Number one is external loading, number two is side sway. Alright, so we have to have the diagram subjected to external loading only. So we will make the this diagram as non-sway frame. This is non-sway frame, diagram number 2. This is non-sway frame. By putting an imaginary pin support here, so due to the pin support, there is a restraining force in this direction. The external loading 8 kN per meter is remain. So this non-sway frame is now properly restrained and only has external loading. Okay. Next is another frame. This frame, when we plus with the second frame, okay, this is called as diagram 3 or figure 3. This is side sway frame. Alright, based on the principle of superposition, if at C for diagram number 2 there is a negative R due to the pin support, so there is a restraining force that is subjected in opposite direction. This is positive R plus minus R. This is equal to 0 here. Alright. Okay, so for the side sway frame, diagram number 3, we have the side sway frame, and this is subjected to side sway. Side sway or delta only. There is no external loading here. External loading. Yeah. Alright. This is diagram number 1. Diagram number 1, original frame. Diagram number 2, non-sway frame. We make this frame as non-sway frame by introducing the pin support at C, so the frame is now become properly restrained. So we will analyze diagram number 2, frame number 2, due to external loading only. And diagram number 3, we have side sway frame. This is subjected to positive R. So this positive R is occur due to the restraining force in diagram number 2. In diagram number 2, due to the restraining force in the left side, so there will be a restraint and R in opposite direction that is occur at C. So this is the side sway frame. This we will analyze. We will have the FEM for this frame due to delta only, and in this case there is no external loading. Alright. Anyway, for the side sway analysis, we have to introduce diagram number 4. Diagram number 4. So we have to introduce diagram side sway frame subjected to R prime at point C. Alright. Okay, there is the frame. It is a frame subjected to R prime. Subjected to R prime, and due to this there are delta at B and C. So this is delta prime, this is delta prime. So this is diagram number 4. This is side sway frame. Alright. For the analysis, number 1, stage 1, we will determine the stiffness factor K and distribution factor for each element. Stage number 2, we will do side non-sway frame first. Non-sway analysis. Non-sway frame analysis. Okay, 2A. This for 2A, we determine the FEM. This is due to external loading. B, we will determine the end moment using moment distribution process, and this will produce the M naught. And stage number 3, stage number 2C is we have to determine the restraining force value. Restraining force R. Okay, all this will be referred to figure 2. For number 3, we have side sway frame analysis. We have 3A. We have, in this stage, we will analyze frame with side sway, and for the first step in this side sway frame analysis, we have to assume FEM due to side sway or due to delta, and we will calculate. We will assume for one column only, one member only, and we will calculate for the remaining element or remaining members based on the assumption that we made. B, we will determine the end moment. M prime. So this is all based on prime, because we actually analyze diagram 4, figure number 4. So C, we will calculate the R prime value. So stage number 4, we will calculate the final end moment. Final end moments, MF, by using the formula here. By using this formula. By using this formula. Okay, we will continue this analysis in the next lecture.